Great. Well, thank you all for coming to our second office hours presentation. My name is Steve. Just going to do a brief introduction before we dive into the questions, because that's why everybody is here. You may have heard me in a number of situations. I do lots of online training. I've done lots of instructor-led training as part of the Intel FPGA training group. This year will mark my 16th year with the company and 14th year in the training group itself. And I've taught hundreds of engineers in all sorts of different topics. You can see those listed there. And if you wanted to contact me, email address is very easy, steven.strel@intel.com. I still look exactly like that. I guarantee it. Change slides. Okay, so why are you here? Well, what is this SignalTap you speak of? Maybe you have heard your coworkers or somebody talk about SignalTap. You didn't know what that was. You're coming from somebody else, a competitor perhaps, and you're not familiar with our debugging tools, and you just want to, jump on the bandwagon of our really cool embedded logic analyzer. I've heard about SignalTap and tried to use it, but I just don't get it. Makes sense. There's a lot going on there, and if you have questions about that, of course, I will be able to answer. I have extensive experience using SignalTap, and it works great, but what are some new features or other things about the tool I should know? So in this hour, I hopefully will be able to hit on some of those new features if you have not looked at SignalTap for a while, and just uncover some other tips and tricks and things that you might not be familiar with. Oh, I have to recompile just to change a trigger setting. So yeah, one of the biggest issues that people have with SignalTap is you make a change and then you have to recompile your design. Believe me, I know what you're talking about. We'll talk a little bit about that in this hour, I'm sure, as well. I'm just stuck. Yeah, I've heard it before. Or you still call the tool SignalTap too. It's now just Signal space tap. SignalTap embedded logic analyzer. So we have lots of additional resources available. Some of the online trainings were included in your invitation email, so you can get links to those online trainings. And we do have a full day instructor-led class that talks about SignalTap, as well as a number of other on-chip debugging tools. We don't teach it too often, but if you are interested in it, you could let us know, and we can see about scheduling it. So that is another option for training. And as far as documentation is concerned, there are specific user guides for Quartus for debugging for the lighter standard edition of Quartus and the Pro edition, all available from the Intel website. So the ground rules for this, any question you can think of about SignalTap is fair game. Lay it on me. And Susanna will give you the instructions for that in a moment, how to do that on the phone or in the chat. If it's a detailed design-specific question, I'll try to answer if I can based on your description, but I don't want to take up too much time with questions so that we can get the most questions in that we can. If I can't answer your question in a reasonable amount of time, I'll try to follow up with you. We're keeping track of everybody who's registered, so leave a message in the chat and with an email or something, and we can follow up with you. And I may point you to your local FAE if you need more assistance. If you have not been in touch with them, they are very, very helpful for this sort of thing. All right, Susanna, do you want to explain the question?
Sure, okay. So hi, everybody. I'm Susanna, and I will be the moderator. So during this, there's going to be two ways to ask your questions. First is by voice, so you can unmute yourself. The unmute button is at the bottom of the WebEx GUI. And the second is by chat, and if you ask by chat, then I see all of those, and I will ask Steve by voice, because it's pretty hard for him to look at the chat and be sharing a screen at the same time. Okay, and so with that, we will open it up for questions. I've already got a question.
All right.
Most likely, yeah, start sharing a screen. Okay, so the first question, Steve, did you read it, or should I read that? Or I'll read it out loud so everybody
I didn't get a chance to read it yet. Okay. No, I saw it. It was long.
So this user says, I am using a FIFO to get a data from an ADC running at 125 megasamples per second, going into another clock domain running at 250 megahertz. So basically crossing clock domains. The clock that he uses on SignalTap is the ADC clock. And I have a FIFO write and read enable signals such that I write data 8 words into the FIFO and read it 8 words a few clock cycles later. And then the write and read sequence repeats continuously. Sometimes the ADC data and the input data to the FIFO are different as displayed on the traces on SignalTap. So what could be wrong? Also, when I read the FIFO data out compared to the FIFO data in that was saved, they are different sometimes. So what could be causing this? And would you recommend using a different clock for the SignalTap sampling, such as 250 megahertz, to sample the ADC data that is clocked in at 125 megahertz?
Wow. Okay. Yeah, I'm looking at it in the chat right now. So there's a lot going on there. You're running at a pretty fast speed. Which clock did you say you're using to sample the data? The 250? I think it said the 250 is the one being used for sampling in SignalTap.
It sounds like the 100.
Oh, the 125. Yeah, using the 120. Okay. There's a lot going on there. So where do I start? I think that, well, first of all, good rule of thumb, when you're using SignalTap, use the fastest clock that you have available to you, because we're talking about sampling here, and always using a faster sampling clock is going to give you better results. And funny thing, the design that I have here that I was going to have just open for demonstration that I looked at earlier this week, it runs at 100 megahertz, but I accidentally selected a 50 megahertz clock. And so I was missing half the data, and I kept scratching my head where did the rest of the data go, until I realized, oh, silly, you picked the wrong clock as the sampling clock. So you definitely want to pick the fastest clock that you have. Looking at your question, I don't know. It could be timing issues. I don't know if your design is meeting timing or not, or it could be dropped samples because you're using the 125 instead of the 250. So yeah, the chat kind of drifted off at the end. I have also noticed that when I am using a faster SignalTap clock while my ADC is running, and then I don't have any other text after that. So it could just be your sampling clock. So I don't know if that answers the question, but if you have more follow-up, you can certainly put that in the chat and follow it up to Susanna. But
yeah, that question got cut off. You might have reached the limitation of the WebEx chat or something. That the last part of it is as well. My ADC it should be running, but that word got cut off, and the rest of and anything after that was cut off. Yeah. So I think.
What else we got, Susanna?
Okay, so another question is they're wondering if SignalTap, if it works like Trace, if it's real time, or how exactly does that work?
Good question. So, so SignalTap is meant to be able to capture high-speed signaling that you could never see, obviously, when you're seeing it run in real time. So SignalTap is not a direct trace. What happens when SignalTap captures data, it gets stored in on-chip memory on the FPGA, and then that gets transferred over JTAG so that you can see these lovely waveforms of your data. We do have other tools that do live trace, like the in-system memory content editor to monitor the contents of on-chip memories, and in-system sources and probes, which allow you to basically, it's like sticking an LED on a point in your design, but no, SignalTap does not do direct data tracing. JTAG's too slow for that.
Then we had another question. So what is the rule of thumb for the clock? Is 2x a good option for the sampling clock?
That is a great rule of thumb. That's the recommended sampling frequency to try to sample at 2x whatever speed you're trying to look at. So if you do have that clock available to you, then definitely use it.
Okay, so we have another question. This is a bit tougher. So this person uses a Python text executing on Windows to control their device under test and the connected Strata X10 FPGA. Is there a way to shell a script that triggers a signal tap trace and saves that trace to a file with timestamp or iteration number in the file? And this would be inside of a loop that their test keeps executing.
Oh, wow.
Okay, so scripting.
Yeah, scripting is, I'm not, oops, hold on one second here. I don't know what that is. Yeah, I'm not a super expert on that. SignalTap is fully scriptable through Tcl scripting. I heard Jason, so that means we're talking about Java, right? Yeah, I'm not an expert on that, but yeah, SignalTap is fully scriptable for starting the logic analyzer and reading the results back. You can also, if you want to be able to parse text, one of the output options for SignalTap is to make this output as a list file, which is an ASCII text file, instead of the graphical waveform. And you could parse that with a script if you want to analyze the output. So I don't know if that answers your question, but yeah, SignalTap is fully scriptable for normal operation.
Yeah, so the person said not JSON, but Python, but
Python, okay.
Yeah, the scripts run at the command line, so it should be pluggable into Python using a call. So I think you can do it. If you want more details, you could follow up.
Susanna is my scripting expert, so I'm glad she can answer that.
Okay, and so that was another follow-up. So it sounded like they got their answer, or at least what they needed. Okay, so another question that comes in, they're asking about how complex can the trigger conditions be, and are there kind of any limitations on that complexity? Okay.
Good question. So in recent years, we've added tons of additional options for creating triggers. The only limitations are, resource use and your time, basically. The more complex the trigger conditions that you create, obviously the more logic is going to be required to implement those. And so, of course, your device needs to have those available. Just as something to show off real quick here. So right now I have this locked. Everybody misses this control but it's super handy, so you don't accidentally change stuff and require a recompilation. But I'm going to change that to allow all changes here. And I'm just going to add an extra trigger condition column just so that I can play around with that. Let me use my mouse instead of the trackpad because it's not working well here. Okay, so let's just add another column here that we can play around with. So I have it set on basic triggers. You'll notice that we have basic and triggers, which is what most people are using. Basic or is a way of being able to compare groups and subgroups of signals together in different ways. And then we also have comparison, which are direct comparisons, which are kind of a subset of the basic or, and then advanced triggers. So if I go down to advanced trigger here, you have the advanced trigger condition editor. And it's kind of neat because you can, just drag and drop here and set values and stuff. People complained about this, like, oh, I have to learn another GUI to set up my trigger conditions. But we've recently added, in the past couple years, I think, the custom trigger HDL component here, where you can actually go in here and you can provide HDL code to define your trigger. So you can write it at HDL code. I'm not going to go into the details of what you need to put in your HDL to do that, but now you can get away from a GUI and just write HDL code. But as far as the limitations for this, there again, it's resource usage and compilation time. So.
Okay.
Next.
So the next question is they're using SignalTap on a Stratix 10 SX dev kit with Linux running. So Linux configures the FPGA in the second stage bootloader and the kernel boot up. So the FPGA gets configured while the HPS is booting up. Afterwards, when I set up the JTAG connection, 24 megahertz does not work, and the error says the FPGA is not configured. However, when I switch the JTAG connection to 6 megahertz, it works. And why is that? And yeah.
Yeah, that's a common solution that our support gives out. Sometimes the on-chip debugging tools don't like 24 megahertz. I've never understood exactly why they don't like 24 megahertz, but sorry, kilohertz, and they work fine at 6 kilohertz.
Oh, it's megahertz.
Yeah. Oh, megahertz? Am I thinking? Wait, so for the JTAG clock, are we talking?
For the JTAG, yeah.
The
but
JTAG,
basically, it's just slowing it down. It works.
Sorry, I'm getting my mega and kilohertz wrong. Yes, it's 24 megahertz down to 6 megahertz. Yeah, that's a common solution, and I don't know if it's a limitation with our JTAG interface or what. I do know that sometimes if you have multiple JTAG tools open, like SignalTap and another on-chip debugging tool, or using System Console and Platform Designer at the same time, the JTAG starts having issues. Yeah, that's an unfortunate thing that I've seen, and I've actually had to do it as well. And 6 megahertz is annoying when you're trying to do stuff, and having to remember because it always defaults back to 24 megahertz. But yeah, I don't know. That's the kind of thing that would want to talk to support about and try to find out what in your design might be causing that.
Okay. Okay, so the next question is, I have noticed that when I'm running a faster SignalTap clock, let's say 250 megahertz, while the ADC is running at 125 megahertz, I would expect the ADC data to be constant during 2 clock cycles of the SignalTap sample clock. But I see that the data keeps changing when the SignalTap clock is running and before a new ADC data is read in. Every other clock cycle of the SignalTap clock. What could be causing this, and how can I fix this?
So this is obviously the person from earlier. So when you do use the 250 megahertz clock for sampling, this is in the chat just so I can kind of read what you just read to me. Yes, I see it. Okay. When I use different sample, oh no, is this in the chat, Susanna?
Just no, so I can relay it to you. There you go.
Thank you. I see the data keeps changing when the SignalTap clock is running and before a new ADC data is read in every other clock cycle of the signal. I'm not sure. Well, you say the data keeps changing, but I guess you're saying that you're not expecting it to be changing. Is it like reverting back to a previous sample or something? It's not entirely clear what you mean by the data keeps changing. So is there any more detail on that, Susanna?
Well, I think since it's a faster sample clock, he's probably just seeing the transitions happening. So he's sampling at 250, but really the clock domain it's coming from is 125.
Yeah.
Sorry,
so he's.
Can I explain on the? Sorry.
Sure.
Yes.
Yeah. So I have my ADC data coming. The clock is the 125, so I expect and the SignalTap is running at 250 megahertz. That means it's twice as fast as the ADC clock. So
yep.
I would expect the when I look at the traces, I would expect after 2 clock after 2 sampling clocks of the SignalTap, I would expect the ADC data to change because it is running at half the rate, right?
Right.
But it is not that way. Like every clock cycle of the signal tap, the data keeps changing, even though I expect, because the ADC updates data at half the rate. So, but it keeps changing every clock of the signal tap. I hope that makes sense. I don't know if it's clear.
So what you're saying is that you're seeing transitions on the middle clock that you're not expecting to be seeing. Is that what you're saying?
Right. Okay. Exactly. Yeah.
So that makes me go back to timing. Is your design meeting timing closure?
I need to look into that. Thank you.
Yes. It's possible that your design is not meeting timing, and that you're getting transitions that are happening too late, so they're getting sampled by the incorrect clock from signal tap. So yeah, I think timing closure, looking at your SDC file, that might be something that you need to look at, because signal tap is functional only. So situations like that, I would look more at timing, or start looking at timing if you haven't already. So.
Yeah. Thank you. I really appreciate it.
You're very welcome. And we're having a timing closure office hours next month. So there you go.
Thank you.
Okay, so another question that came in is there a feature to count events or wait some number of clocks and then trigger?
Is there a feature to count events and then trigger? Well, let's think about that, how you could do something like that. Yes, so there's multiple ways of doing something like that. Probably the most direct way, I would say, would be use a state machine trigger. So I can show that real quick here. If I down here, oops, not that far down. Where is it? Why am I not? Oh, here we go. Yeah. So if we go to a state-based trigger, so with the state-based trigger flow, in case you're not familiar with it, you can basically build up a state machine and decide exactly when when to start capturing samples, how many samples you want to capture in the buffer. You can get very, very detailed with a state-based trigger. And as you'll notice over here, you have options to insert flags and counters. So you can have flags that can be checked in the state machine to indicate when a flag a flag event has happened, and there's counters built right in. So for what you're talking about, if you want to count a certain event a certain number of times, you could certainly do that. So state-based triggers is one method for doing this. Another method that I can think of off the bat, let me switch this back real quick here. You could have multiple trigger condition columns and have enough for each event that you wanted to look at. That runs into a limit though, because there's only 10. But you could also change your sample type. Your sample buffer. So the sample buffer, as you may or may not be aware, is defaulted to a circular buffer, just one big buffer. But you could turn it into a segmented buffer. And each time a segment is filled in, each time the trigger conditions are true. So you could have multiple segments, and then you could see what's happening each time the event is happening, and then the final segment could have the final trigger that you're looking for. There's a number of different ways of doing this. Probably the quickest for something like that would be with the state-based trigger, and the most flexible would be the state-based trigger.
Thank you.
Sure.
Okay, so the next question is, sometimes I need one trigger condition and sometimes I need two signals ANDed together. Is it better to use the basic and trigger condition in this case?
So, is this in the chat? Sometimes I need.
I can relay it to you.
Oh no, I see it. Sometimes I need one trigger condition. Sometimes I need two signals. Is it better to use the basic and? Yeah, that's the easiest thing to do. You could just simply AND them together. Maybe I'm not just one, and maybe I'm not, maybe you're thinking you mean that, maybe the question is, do you need 2 trigger conditions? And the answer is, if you are looking for both signals to be true, both conditions to be true at the same time, then all you need is 1 trigger condition. If you are looking for a sequence, something happens and then something else happens, then you would use two trigger conditions, because they're analyzed in sequence when you're using the sequential trigger option that I just set here, down here, sequential. So I hope that answers your question.
Okay. Okay, so the next question, when I use signal tap observing 4 signals, the result is correct. But if I add in more signals to observe, there are errors in the timing sequence. And how should I solve this problem?
Errors in the timing sequence.
So
Oh, I see it in the chat.
Yeah, correct data with 4, but incorrect with more than 4 signals.
Gosh, that could end up being a timing issue again. When I'm observing 4 signals, the result is correct, but add for observation more signals, there's errors. That's a tricky one. If it was working fine with 4, and then you're adding more to look at in signal tap, and now things are not working correctly, that could be another timing issue, like what I was speaking about earlier. One of the things to be aware of with signal tap is, and I think people sometimes forget this, is that signal tap is great. I love it. I'm giving an office hours about it. The problem is that anytime you add a stub on any wire, which of course is what you're doing when you're adding signal tap to your design, you're adding another branch off of your signal, that can affect timing in your design. So, of course, when you're finished with your design and you've debugged it and everything, you remove signal tap. You don't leave that logic in your design. So it's entirely possible, unfortunately, that signal tap could potentially affect the timing on your design a little bit. So it's a good idea to run a timing analysis with signal tap disabled and see if your design is meeting timing and what kind of slack you have. And then when you add signal tap, if you start having issues, then you know that signal tap is to blame and it's not the design. So I don't know if that answers your question, but I hope it does.
So back to timing, it sounds like.
Yeah.
So when you add signal tap into a design that's fully timing constrained and closed, do you need to worry about adding extra timing constraints just for signal tap?
No, you do not. Some designers, just to be safe, you could add false paths on on the blocks for signal tap that should. So signal tap shows up in let's see if I go into my project here. So you see AutoFab. That is basically the logic behind the scenes that gets added in order to hook signal tap up into the JTAG. So you can use that as a reference, and sometimes designers will try to isolate that or add false paths to that. It's certainly something that you could try to do, adding false paths. I don't know that it's going to do much because it will save you timing analysis time, but the wires are still there. The wires don't go away, so it could still affect timing.
Okay, so another question is, sometimes this customer needs to view 2 signals in 2 different clock domains. Does signal tap support that? So for example, one signal tap clock with clock 1 and another signal tap with clock 2.
Signal tap does support that, but you would want to create another instance of signal tap. So each signal tap instance uses only a single sampling clock. So if you wanted to look at signals in one clock domain and signals in another clock domain, you certainly could add all those signals to a single instance, but they're going to be using the same sampling clock. So you need to be aware of that. The best solution for looking at multiple clock domains is create multiple instances. Now, again, if you're looking at the interaction between signals across clock domains, that's not really going to be what you want to do. You might want to all add them into a single instance and choose the faster clock, like what I was saying before, as the sampling clock. So.
Also, could you show the trigger that they could chain together the two instances if they wanted to, the trigger in?
Oh, to chain them, yes.
Yeah.
That is a good point. So yeah, so if you do have multiple signal tap instances here, I can actually I'll create one real quick. I'll create another instance here. So I got 2 instances here, and you can, as Susanna just mentioned, yes, you can chain signal tap instances together. So I can turn on down here for this first instance a trigger out, okay, and then on the second one, I turn, oops, gotta switch over to it. I can turn off trigger out on this one and turn on trigger in on this one and set that to instance. And you'll notice that now I can select auto signal tap 0. Okay, so now what happens is the first instance will trigger, and then that sends a signal to the second instance, and then the second instance would go through its trigger conditions. So they can be, each trigger instance can be connected to another one. It is sequential, though. It's not simultaneous because it's actually sending a signal to the second instance here for triggering. So, but you can think of this, I always like to say that the trigger in here, you can think of it as trigger condition 0. Basically, that trigger condition has to occur before trigger condition 1 or any of the other trigger condition columns in this instance.
Okay, so the next question, I might need this person to chime in a little bit to explain it, but it says, in fact, wiring a signal to signal tap may prevent the synthesizer to throw away that signal, which could be the default state for that signal. Oh, okay, so I think
trying to preserve signals.
Yeah, signal tap will keep the trimming from happening.
Yes, if you tap pre-synthesis signals in signal tap, then those signals are forced to be preserved through the entire compilation process, whereas it might have been possible if they were not tapped in signal tap that they might have been optimized away for some reason or another during compilation.
Okay. So I guess that was just a point that yes, it can keep it from trimming in synthesis. Okay, so another question is, do you have to do a full compile when you want to make changes to your tap point? So I guess you could go through what you
alluded to before.
To compile it all, and what you just have to do a partial compile.
Sure. So one of the things that trips people up, like I was saying before, is when you have to recompile and trying to avoid recompiling as much as possible. So this setting, as I mentioned earlier, is your main option for that. If you turn this to allow trigger condition changes only, which is what I had it before, you can change values in here and you don't have to recompile, which I use all the time. But if you do need to add additional signal nodes to tap, then or need to make certain changes in the for the basic settings in the signal configuration section of the logic analyzer, yes, you will need to recompile. There's a few things that you can do to minimize this, and things are actually changing in 21.1. The newest version of Quartus coming out soon that I'll talk about in a moment. But the main method right now to minimize compile time is the use of node allocation. So you'll notice over here in the signal configuration section, a nodes allocated option for the buffer. Where's the next one? And nodes allocated for the trigger. So basically what this is saying is that you are allocating space essentially on the signal tap instance to be able to add additional nodes or increase the size of the buffer later on. Okay, so for example, you'll notice that I have 923 nodes tapped in this design. So when I set this to auto, that means that that's how many nodes are tapped. And if I wanted to add more nodes, well, I'm going to have to recompile from scratch. But if I switch this to manual, and then let's say I bumped this up to 1,000 nodes, now what I could do is I could add the additional nodes. Well, first, I would have had to do a full compile before I could have done this. So I would have fully compiled with it set to manual like this. But then if I wanted to add more nodes, I could add those nodes and then use a rapid recompile. So the rapid recompile allows you to add additional nodes or change the size of the buffer based off of the allocation you have, saving you some compile time. We've had this feature in the tool for a few years now. It's kind of hit or miss. So in 21.1, this feature is moving to a true ECO flow. So ECO means engineering change order, and ECO in the context of our devices means that you make changes to the post-fit netlist of the design without touching the existing post-fit design. So in 21.1, we're going to get smarter about looking at the changes that you've made in here, matching what you've added or changed versus the post-fit netlist, and being able to make ECO changes, add extra routing wires, add extra logic if possible to implement those ECO changes and greatly reduce recompile time when you make changes to your signal tap logic analyzer. So that's coming as a beta feature in 21.1. And later on, of course, that will get integrated fully into the tool. But those are ways to, that's going to be the main way to quickly make changes to your logic analyzer and shorten recompile times.
Okay. Another question is, how large are the nodes that get inserted for signal tap, and how many can you include in the design?
Okay. Good question. So that's getting into logic resource usage, and it is not showing it here. So hold on one second. All right. So I think that this is a feature that is currently missing in Pro, which is the resource allocation information, where it would show you how much logic, how much memory resources your instance of Signal Tap is using. I don't know why that keeps popping up. Let me hide that. So in the standard edition of Signal Tap, you can view that information. You can see how much logic, and as you make changes to your trigger conditions, the buffer, it updates on the fly to show you an estimation of resource usage. And I thought that was in here, but it is not in here, so maybe they have not implemented it in Pro Edition yet for some reason. But that is the main way to know. Other than that, then yeah, you got to go into your after you compile the design and look at the resource usage to see usage there. So.
Okay, so it's all dependent on how many resources you have. There's no innate.
It's all dependent on how many signals you're tapping, the complexity of your triggers, the size of your buffer, really how big your signal tap instance is going to be.
Okay. Okay, so. Is there any communication channel that you can use besides JTAG to get the information back out of Signal Tap?
So for basically forever, yes, it has been JTAG only. What would happen is, again, your Signal Tap would trigger and the data would get stored in an on-chip memory buffer, and then that data would get transferred over JTAG. Recently, we're starting to work on adding support for over Ethernet, though it will still use the JTAG behind the scenes, but it would be able to then transfer the captured data over Ethernet, and even I've heard inklings about it over PCIe. But right now it is JTAG only, but I expect that to change in coming versions of Fortis.
Okay. So this person wants to know how they can use storage qualifiers and what exactly they're for and how they work.
Great question. So storage qualifiers, I just funny quick side story. So, you know, I come from a board design background, and I had used, you know, the honking logic analyzers, bench logic analyzers. And one of the things that was always handy about those is not only besides the fact that you can store a huge number of samples, way more than we can store with SignalTap, but also that you could choose options about exactly what samples you wanted to store in that huge space. And for years, we didn't have that feature. And I would say to the engineer, so is storage qualification coming? Is storage qualification coming? And then it finally came. And what it does is it does just what I said. It allows you to filter the samples that actually get stored in the on-chip memory buffer so that you can make most efficient use of the on-chip memory buffers. So the default is continuous, basically that when a trigger occurs, the buffer gets filled up with a few samples before the trigger occurred and a number of samples after the trigger occurred, okay? But what you can do is you can use a storage qualifier to reduce that and save buffer space. So for example, the input port option, that means that you can take a signal, any signal that you want in your design or coming from the outside world, and say, as long as this signal is active, samples will get stored in the buffer. As soon as this signal is not active, stop storing data samples. Okay. You could have a transitional storage qualifier, you know, only store a sample when the signal goes from low to high or high to low. With conditional and start and stop, it adds extra columns on in the node list here, so you can create another condition, and when that condition is true, that's when the samples will get stored in the buffer. And finally, and start and stop, like I said, is related to that. You can just choose when to start storing samples and when to stop storing samples based on a condition. And then you could even get even more complex and have a state-based storage qualifier, which uses the state-based trigger engine to build another condition that's a state machine. So you have lots of options here. What happens when you use a storage qualifier, there are going to be discontinuities in the stored data. And if you have this option turned on, record data discontinuities, it will show indicators in the, I can't show it here now, but it will show indicators in the triggers where there are data discontinuities, where samples have been dropped. Okay. One other thing to note about storage qualifiers that sometimes confuses people is that with a storage qualifier, there is the possibility that the logic analyzer will just keep running. And the reason why it keeps running is because of your storage qualification, maybe you haven't fully filled up the buffer. Because remember, the logic analyzer only stops automatically when the buffer is full. So if you're using a storage qualifier and it says in here, it'll say that it'll say that it has started capturing samples, but it won't stop, then you can manually stop the logic analyzer, and then you'll be able to see the partially filled buffer. That happens a lot with state-based triggers as well, because you can have the same type of control over when samples are stored in the buffer. If the buffer is not full, the logic analyzer just keeps running.
Okay.
Oh, any other questions?
Yeah, there's more questions. I just
Great.
want to make sure you were finished.
I am finished.
This person would like to know more about how storage qualifiers work.
That's what I just talked about.
Oh, I'm sorry. Okay, so we got to that. So, okay, this the next question is about if they have RTL that they would like to trigger something in SignalTap. What is the best way to incorporate that trigger?
So that kind of goes back to what I was talking about before. Now, of course, if you have RTL code, you could just include that in your actual design and have a signal and use that as a trigger signal. But like I said earlier, what you could have, and let me set this back to continuous here, just as a reminder. So for this second trigger condition column, if I go to advanced, like I said, you can create a custom RTL trigger here. again, you'd want to look at the documentation because it mentions specifically what signals you need to put in and how they will work with the logic analyzer. It tells you exactly what signals and how to control them. But other than that, you can write your own RTL code and create a completely custom RTL-based trigger condition.
Okay, so the next question is, can you explain about signal tap not being real time? So I think that means, you know, how does it capture the signals? Is that in real time and then report it back to you? Like, just how does that flow kind of work?
Oh, yeah, that's what I was talking about. I talked about that earlier as well, how data gets stored in on-chip memory buffers on the chip and then gets transferred over JTAG when the logic analyzer is finished.
Okay. So the trigger itself is real time, right? So it's triggering immediately because it's built in logic. Yeah.
Yes, that's a very good point. The trigger itself is happening in real time. That's actual logic that's running at speed on your device. But the actual you know, the data you're seeing is from when that trigger actually occurs, which by the time it gets to you and you see it on your screen is already in the past, of course.
Okay. Okay, so for this one, they would like to know more about the OR triggers and the AND triggers, and maybe we could just go through that Dropbox in general and explain what some of those mean.
Absolutely. So basic AND, of course, this is the most common. This is what it's set to by default. And of course, with a basic AND trigger, that means that all of these conditions have to be true. Okay. So in this example here, the only thing that I changed from the don't care was I was looking for when the right address on this DMA is looking at address 4. Okay. Now, if I wanted to create a basic OR trigger, let me show you what I mean by that. So with a basic OR trigger, you have a lot more options, okay? But the OR in the name of the basic OR is a little misleading because you can do OR, but you can also do other types of comparisons. And the comparisons that are checked for or these other types of comparisons are between groups of signals. So in Signal Tap, you can group signals however you want. So you can see here that I grouped signals for this DMA. And then, of course, there's natural grouping when you add, say, an entire address bus that becomes a subgroup. And to group signals, you just select them. In case you weren't aware, you right-click and you select group. And you can ungroup nested groups as well. But what it means is that the top level group, so for this DMA, it's an OR trigger here. So the OR is between next level signals and subgroups. If I right click this DMA control address signal here, you'll see it says OR right there. But you'll notice that I can choose other options. Okay. So what this is going to do is it's going to do this type of comparison between the signals in that subgroup. Okay, so right now what it's going to do, if I expand this, so it's going to do an OR trigger of these 3 signals in the address. Okay, I don't have them set to anything, but let's say, I set them to, going high. What that means is that when any one of these signals goes high, then this OR is going to be true. And then that is compared with other subgroups within the main group. Okay, and it's compared based on this. So again, here I could change that from OR to another type of comparison. So basically what it allows you to do is do any types of comparisons within groups and subgroups, and then have a final Boolean true or false whether the trigger could occur. Okay, so it's doing a Boolean OR here. When any of these is active, for example, that goes true, and then that is compared with the other subgroups and the other signals in the overall grouping option selected up here. Okay, so basic OR is a little misleading, unfortunately, because you can have it, you could have it as NOR. how you want to compare the different groups and signals within a group. But it's always for how you want to compare the signals between each other within groups and subgroups. Any questions on that? Or any more questions on that?
I had another question come in, so let me read it real fast.
Sure.
So if you change a trigger condition in a group, does that trigger a recompile?
No. So being able to, for basic OR, well, let me make sure I'm telling the truth. I'm pretty sure that it does not. Yeah, so as you can see, I can make change. So once I've allowed trigger condition changes, so that means that I can make any of these changes. If once I've selected this as a basic OR trigger before compiling, I can change these comparison types any way that I want once the design is already programmed into the device, and change how these signals are compared.
Okay. And actually, do you want to take a tour of some of the stuff that you can change without having to recompile it all?
Sure, real quick. Basically, it's most of so obviously you can't change how the signals are used for data or part of triggers, but you can change levels. As I mentioned, once you selected basic OR, you can change the way that the comparison is performed. You can change signal levels that you're looking for any way that you want. Over in the signal configuration section, most stuff you cannot change, as you can see. Really, the only things you can change are the trigger position, which is just basically where the trigger is located within the data. Can add more trigger conditions, that's for sure. And if you have a trigger out, you can change it to be active high or active low, but that's really it. So that's why I like this lock, because it saves me a lot of compile time from accidentally making a change that requires a recompile.
Okay. Can you change the comparison values? Does the red mean you can't?
Nope, you can change those.
Okay, so you can actually.
Yeah. Yep.
Okay. Good.
Now, there's different restrictions if you're using a power-up trigger, which I could show real quick. So let me turn this back.
Oh, actually, it might be worth going through what a power-up trigger is. That
Sure.
was something I didn't know for a long time.
Okay. So a power-up trigger, enable power-up trigger here, you just right-click any instance. It creates a sub-signal tap instance of the main instance. And what that means is that one of the issues that you might be having when you're trying to debug your design is during reset. You power up your design and it comes out of reset, and then you've got a bug. And normally you cannot look at any signals until you're actually able to come in here and start the logic analyzer. The whole idea behind a power-up trigger is that you want to look at signal activity before you're actually able to come in here and run an analysis. So by enabling a power-up trigger, you can come in here, create this sub-instance of SignalTap, configure it how you want. Most of it has to match the main trigger. So a lot of the signal configuration stuff you can see here is grayed out. Okay, but you can make changes here that are different from the main trigger. You notice you can't change the comparison type for the basic OR. Oh, that wasn't a group. You can do it for group, sorry. But you can make changes such that these trigger conditions are different from the trigger conditions of the main trigger. So you can have it look for events that are happening before you come in and click Run Analysis. What happens then is if the power-up trigger condition occurred, then when you do first click Run Analysis here in SignalTap, the first data set that you'll see is from the power-up trigger, not from the main trigger. Okay, so that way you can see what happened after reset, but before I was able to start the logic analyzer.
And my experience when I was an FAE was this was very useful when PLLs weren't locking and such, because that happens before you can ever, actually hit that you'd like it to trigger. So this is a good way to debug that.
Yes.
Okay.
Yes.
So guys, we're we've only got about 5 minutes, so make sure if you have any more questions to get them into me. I'm going to ask Steve about some stuff that we just like to highlight while you're here. So signal tap use and partial reconfiguration and signal tap use with an SOC. If you want to talk about that, Steve, or anything else you want to highlight, we don't have any more questions, but since we only have 5 more minutes, just if you want to highlight anything while everybody's here.
Let's see. So signal tap with partial reconfiguration. If you are going through the partial reconfiguration flow, yes, it is possible. There's 2 ways to use signal tap with partial reconfiguration. So for those who aren't familiar with partial reconfiguration flow, it's the idea of preserving essentially the I/O of your design and being able to replace during runtime parts of the internal logic. And you can trigger a partial reconfiguration at any time while the design is running. The problem with that with signal tap is that if your design is changing, how does signal tap work? So if you can have signal tap located in what's called the static region of your design. That's the part of the design that does not change with partial reconfiguration. And there's no issues with that. But you can also have signal tap in a region of your design called a PR, or partial reconfiguration region, that does change. However, you have to add some IP on both sides to make it work. So you have to add certain signal tap and some special IP in the PR region, and you have to add some special IP in the static logic, the logic that doesn't change, so that they'll be able to communicate when signal tap is there. So it's a little bit trickier, but it is possible to debug logic in a partial reconfiguration region while the design is actually running. And then you mentioned SOC use with signal tap.
Yes, if you want to highlight that.
Yeah, so just real quick, since we are running out of time here, you may have noticed in the at the bottom in the trigger in and trigger out sections of the logic analyzer. For trigger in, the HPS can generate a debug signal input to signal tap. So an event can happen on the hard processor that can be used as a trigger into signal tap. And also signal tap can generate a trigger in signal to the HPS. So that can be used for if you're executing code on the hard processor, you could break the code in your debugging tool and see what's happening on the hardware side, the FPGA side of the device, when something is happening in software. And we also support the event feature of the ARM processor, so you can indicate what event, when an event is happening, it can get highlighted in the event trace on the HPS. Do you have any last minute questions, Susanna?
No, that's all we had.
That's it. Oh. Okay. Do I have anything else that I could talk about real quick? We got 2 minutes.
I guess, do you have any stories or anything that you've done that makes it really large that you weren't expecting it, or I don't know?
Oh, I can give some good sage advice right here at the end about signal tap, because I do have a story. Very, very quickly, years and years ago, there was a customer whose device was 95% full, maybe. And I was in apps back then, and they said, we want to add signal tap to this. And I had to keep, my mouth closed, because the lesson I want to give to you is that if you want to use signal tap, like other planning, it should be a part of your planning of your FPGA design, because if you do not have space in your device, you're not going to be able to add signal tap later on. So plan for signal tap, think about the resource usage, and like I said, I wish it had the estimate here. I should find out about when that's coming back into Pro, but being able to know how much resources it's going to use is important as well. So plan your use of signal tap for some point in the future, because chances are you will want to use it.
And then we did actually have one more question trickle in. Is there going to be a time quest session soon? And that actually leads into what we will have next.
Yes,
for you all.
next month we are planning on having a timing closure office hours section. So that is in the works for next month, for February.
Okay, and if you got an invite to this one, you should get an invite to the next one because we're using the same, basically the same list to send out those invites. So.
Yep. All right. So, oops, no, I did not want to do that. I wanted to keep sharing real quick. Whoops. Sorry. All right. So that that is the end here. Share. There we go. Back to PowerPoint. So I wanted to thank everybody for attending. There will be an email going out with a link to a survey that you can give us some feedback on this. And also, like I said, you all who are connected are the first ones to get access to the recording. And that recording should be up in the next day or so. So you'll be able to get access to this recording. And that's all I have. Susanna, do you have anything else that you wanted to say?
I just wanted, there will be a timing closure office hours next month. So look for the invite to that. It has not gone out yet. Y'all haven't missed anything. And like Steve said, you'll be getting a link to the recording because I had some questions trickling in about that. And I will monitor chat for the next couple of minutes and then we'll shut the WebEx down. And thanks everyone for attending.
Yes, thank you all for attending. I hope this was useful. And as I said, we're going to try to do this monthly. So
Thank you very much.
You're very, very welcome.